Bismillah Rahman Rahim. Hello and welcome to the ninth video of the Rust series. Today we will be learning about how to write automated tests. We will write some tests for our to-do application that we have built in our last video. So let's get into it. Before moving forward, I think we should discuss about what are tests, why it is necessary to do testing of an application. So first of all, let's discuss about the types of the testing. So there are multiple types of testing: unit testing, end-to-end testing, integration, security, usability, and whatnot. There are multiple types of testing. For now, we will be focusing on the unit testing to test the individual functions, methods. So let's say if we have written a function for add to do, so whether this add to do function is in actual adding to do in our vector or storing the to do into a file system or any other storage. So if it is working perfectly fine, then return true, or the test will run successfully fine. However, if it does not as expected, so it will throw an error, or you can say it will panic, create panic into the Rust language. So I guess we should start with the documentation, Rust of official documentation, and then we will continue with the hands-on implementation of the tests. So they are saying in his 1972 essay, The Humble Programmer, Dijkstra said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly. So this is a history they are showing that how, let's say they have mentioned an example. Say we write a function add two, and that adds two to whatever number is passed to it. This function's signature accepts an integer as a parameter and returns an integer as a result. And so this is an example and it's theory. So I think we should not focus on theory for now, because it's the easiest topic in Rust for right now. So the 11.1 says that how to write tests, and then they are saying that start with creation of a new project, a library. So let's do, yeah, right here, learning Rust. Let's do, let's create a new project. I'll go new minus minus let, lecture 9. You can say yes, lecture 9. Okay, we have a folder run test. Might be it's the older one. Let's delete it so that we will not be confused. Okay, so CD lecture 9. Okay, let's zoom in a bit. Okay. Okay. So, forward space. Oh, God. Moment. Okay, so let's create. Okay, now it's so when we have created a library project, we have it's taking so long. Initially, we have cargo.toml file, and there is no dependencies in it. And we have the starter file, the library lib.rs, and we have a function add, which is adding two numbers, and we have a test for this function. So let's first start with the by running the test. So how to run these tests. We will explore about the syntax later on. So let's start running test. So you can see waiting for file, and yeah, running one test, it works. Test result, one pass, zero failed, zero ignored, zero measured. Let's just update the code. So left and right, there are two. The function add is accepting or is expecting two arguments, left and right. So let's say if I, and the result will be the answer. the result will be the return statement, or the answer will be returned from the add function, and it will be saved into the result variable. And so it is comparing. So for now, just ignore as it equals to. If we will learn about this macro later on. So result, and let's just update this number and save it and just run cargo test. So, okay, yes. So test result failed, 0 pass 1 failed. Why it is failed? Because the answer is not equals to with. So I was expecting that the answer will be 5. However, the result is 4 because 2 plus 2 is 4. So now let's continue with the documentation. So they are explaining what the syntax is all about. They are explaining everything, and then they are starting with the example. So before moving forward, let's just understand the syntax of words. Initially, whenever we want to write tests, we have to follow this syntax. Starting, let's just remove everything. We have to write CFG, and in the uh, parenthesis, we have to write test, which means that we will be writing test from the next line. Mod test, we have to create a modular structure starting with the mod test. There are multiple ways to uh, align the code, standardize the code by creating different directories. Let's say create a directory for tests and then write individual tests for individual functionalities. However, for now, we will just write tests in a single file. We will cover these kinds of example for now, and then we'll later on learn about the advanced implementations of the testing. So let's say mod test, and then you can change name whatever you want to replace it with. So let's say starting with the let's create a function for now. Function subtract, and then let's say left use U32, right? U32, U. Why I am writing U instead of I? Because it is an unsigned integer. So I don't want the number to be in negative. The number should not be in negative. So that's why I don't want it left minus right. For now, just this is a basic implementation. I know this is not making sense for now. So but let's go with this. So let's say if I want to, let's say, test this function subtract, uh, wi- let's say function test subtract, and then uh, let's say subtract, like answer we will subtract 3 1, and then for now let's just do print line and answer. Okay, let's save it and let's run cargo test, and then there are multiple issues in this code. First of all, the issue is cannot find function subtract in this scope. So this is not able to, however, the function subtract is in the same file. However, it is not able to find this function. It is showing not found in this scope because mod test is in a different modular structure or in a different scope. So if we want to access the subtract function, we should write public, make it public, because by default, all the function methods and everything will be uh, private. So initially we have to write pub to make it public. Now, now another thing, same issue that it is not able to find this function. Second issue, if I want to test a function, so I have to write hash and to test. Now the issue will remain same. The error will remain same at its place. So how to access this function? So let's go back to the documentation and then review how they are accessing the function, because we are all we are accessing everything same as they are doing. However, to access all these functions and everything, we have to write use super there. Now super means to go back to go back to the uh, go back to the previous file, or you can say the, or if you want to go back to the previous directory, or the uh, one step back, let's say // there are multiple options. Let's say if I show you an example, right now I am in folder of lecture 9. If I want to go in, let's say, uh, in this folder, learning Rust, so how I can go back? I can write dot. It means go back to the previous folder, or the folder, uh, its parent folder. So now if I want to go in the child folder like lecture 9, I can cd and lecture 9. Now, if I want to access the whole file, or the content in the lib.rs file. So what I can do, I can write asterisk, and it will allow me, or it gives me the access to all the file. Or if I want to access only the specific function or the file, so I can directly write, let's say subtract. This is the function that I want to access. I cannot find function subtract. Okay, subtract. Now I'm able to access the function subtract, and if I run cargo test, now you can see running one test is passed, because I'm not doing anything right now. I'm not asserting right now and anything. So let's do one thing. Okay, so let's move on to the implementation of assert. So let's understand what this assert macro is. So let's do, there are multiple asserts. So we can go with the simple assert, where it only expects that something will be in result, or we will case कुछ ना कुछ output में मिलेगा. Assert equal, it means that left hand side must be equal to right hand side, not equals assert NE, which means the left hand side must not equal to right hand side. Inhabited, mem initialize, valid, unchecked, zero valid. So these are multiple macro rules that we can implement. So it's starting with the assert, let's say, equals. So now let's say answered for the 3 minus 1, which would be 2. Go test, and then it should return, or it should work. Yeah, test result. Okay, 1 passed. What if I write 3? Now cargo test, it should fail. Yeah, the test is failed. Thread test subtract panicked at source lib.rs assertion. So what does this mean? That if a test get failed, so the rest will get panicked. It will create panic. So it is kind of this. Let's say panic macro, and then let's say uh, uh, left hand side is not equal to right side. Okay. So if, whether the answer is correct or wrong, it will by default create panic. So it's right now you can see left hand side is not equal to right hand side. And then if I write hazard equal to, it will, the test will get failed, and you can see the answer, the uh, because we have passed the custom string to this panic, and hazard equal will create panic, but with a custom message. Let's say assertion left, not let left equals right. It was expecting, but The test get failed because left was 2, right is 3, so it's not equal. What if I do NE? Now, what does this mean? The test should run successfully fine. Yeah, the test is the result okay, 1 pass, 0 failed. So now the basic implementation was easy because it's pretty much it because it's the simplest thing that we can learn right now. Now let's move on to the documentation, continue with checking results with the assert macro. It's uh okay, so they are implementing through structs and everything. So let's start with the implementation. Or I think we should test the to-do application. Where is to-do app? This is the lecture 9. Oh, sorry, learning Rust directory. Where is to-do app? Yeah, right here. To-do application. So this is the to-do application that we have built, uh, I guess, in our last videos or in our last lectures. So let's test this to-do application. Initially, we have to write the default syntax for testing. So let's say cfg test mod test, and then here we can do super. And one more thing, instead of writing super for now, let's just do one thing. Hash test and function test. Uh, uh, okay, test working function, and then just create array. Array, and then hello. Okay, let's zoom in. Okay, can you close? Okay, I think it's visible. Yes, yeah, it's visible perfectly. Cargo test. Okay, cd to do app here. Cargo test. Okay, run with backtrace. Test result fails. Let's say if I create instead of doing anything, let's just run test. Cargo test. Why I haven't implemented anything in this function. It's just I have declared a macro where I am defining that whatever I'll write in this function, it will consider it as the test number one. So if I don't implement anything, it will consider it as the test is successfully running or it's passed. So, and another thing that I want to uh, discuss it with you, that the VS Code is because we have installed the extensions in our first video of the Rust series, Rust Analyzer, and the couple of other extensions. So if I click on the run test, it will automatically run the test. Yep, now you can see it's easy. Instead of writing commands every time, we can click on the button and it's pretty much easy to do it or work with. So let's start with okay, and one more thing, why we haven't written the super this command or this line of code? Because super or these kind of command can is used in when we are working with the library. So right now we are not working with library. The main.rs will be considered as the main file of the program. So there is no issues with that. So what if I create main.rs in the library, and let's just copy the code, whatever, and let's save it. And now you can see what's happening. Main function not create. Oh, okay. Where is the main function? Pub or main. Let's just move everything. Where is function? Okay, now you can see we have the issue that we cannot write super because we are not importing anything within main.rs. Main.rs is the initial file, the base file of the Rust program. So we don't, because it's the root program, so we don't need to write use super and or these kind of stuff. So we can directly work with this thing. Okay. So let's remove this main.rs. Let's move on to the to-do application. And now what I want to do, let's start with the testing of view to-dos. So uh, let's say view test view. Initially, the view to-dos, the to-dos array will be empty. So what I can do, let's do one thing. What is the name of the function for view to-dos? Yeah, view to-dos. So let's do one thing as a equals, okay, and then the left hand side will be view to do's, and we have to pass the to do's array. So let to do's equals to vec macro. For now, let's just test this, and then task, it will be vector of task struct. Okay, to do's. Let's just pass to do's. In return, we will get an empty array. So let's vacuum it, and then okay, the keyboard is okay now. Okay, so what is it is throwing mismatch types, unit type is stuck. Okay, so what I am getting, okay, कि हमें यहाँ पर बताना है कि हमारे पास टाइप क्या है. कैन नॉट फाइंड टास्क नॉट फाउंड इन दिस स्कोप. Whereas the struct task is written in the main.rs. So why it can't be accessed into our into this function, this test function? So how can we access this task struct into this? So that we have discussed that we have an error that cannot find task in this scope. So how to access this task? If I click on this, you can see that we can import it, use create. However, there is another thing that we have discussed already, that we can use super, and then we can write anything. We can access any of the specific function methods into that. However, now there are multiple issues that consider borrowing here, because are expecting the to-dos reference of the to-dos array. So it's here, and now we have an error. So instead of, because it expects the type to be array of vector of task. So for now, because vec macro and an empty macro. Okay, and then expected unit type array or expected unit type of result, yes, means something will be returned, found struct vec macro with none type, because it's the type is not defined yet. So we can do one thing, that we are expecting that the initially the to do's array will be equals to this to do. So let's do one thing, and then view to do's will be to do's array, and then uh there are multiple options that we can opt for. Oh, what? Um, let let's just add one thing. What we are returning from view to do's, view to do's. Okay, so view to do will not return anything. Okay, view to do will not return anything. It will just print out the string. So, so instead of expecting anything from view to do's, we can go for hazard. So let's say now we expect that it should return. Okay, so Gemini, so Google Gemini was responding to something. Okay, so cannot apply unary operator exclamatory mark to type. So now what I have to do is, so what does this mean? That it's not returning anything. So we have to, we can just go with view to do's as an output, so that we get to know whether the view to do's is panicking or not, creating panic or not. So let's say cargo test, it's not creating panic. The test is running successfully. Fine. So what if I want to write test for function, add test, add to do. Now this is the thing. Let's move this let to do's yeah. Um, um, copy this let. What happened? It let to let with mutable, make it mutable so that, and then add to do what is this expecting and what it's returning. Let's review this. Add to do will uh, create do a println, add a task to do, expect the a user input, and then task dot push. So for now, let's just test this function as like use. Let's do one thing here. So let's go for hazard equal, and then add to do's tasks, pass as a reference, and then in output, what I'm thinking that we can go, let's say, make macro, and then let's task, and let's say what this task is task, let's say reading book and is completed. Okay, so okay, so task of to do's, and then what's okay dot to string. Oops. Better tree. I have to own this string. Mutable reference. Okay, I haven't passed as mutable reference. And then mismatch types, expected unit type, struct, found struct, task, vector of tasks. However, at two, it will return. Oh, okay. It will also not return anything. So what we have to do, that we have to let task is equals to, or just do nothing here. Add task. We will add task by getting an input from user, and then let's say we should expect that it should return the left hand side must be equal to right hand side. So what does this mean? So what we can do to do is first index which should be equals to the right hand side. Binary operation cannot be applied to task. Okay, so we are also mm, uh, comparing, or we have already learned in the previous lectures that we have to implement the traits, partial equal, partial order. So there are multiple kind. So what we have to do, we have to implement the partial equals to the uh, struct macro. So let's do one thing, go and add the partial equal, and then come right here. Okay, so now expected struct task, and then found struct vector at, and then let's just expect this, because we are expecting the first index of the to do's, because whenever we add, it will add the first task in the to do's vector, so we can access. Initially we will have nothing, because हमारे पास यहाँ पे इस line पे there will be nothing, an empty array or vector, and whenever we add a to do, it will add something like uh, task, a string, and is completed false, false. Okay, so if I do to do's array, so it can work like we have to pass back macro. If I am expecting that it the first index, I am comparing the first index with this task. So let's test this function, cargo test. So there is nothing, it the program is it stopped executing further. So it is expecting that I will write something here. I will pass the input. So let's do one thing. Hello world. Task get failed because we are expecting the task should be reading book instead of the what I have was hello world. And one more thing. Okay, there is another thing uh, that we will review. Okay, so there go. Task get failed. However, I have passed reading book, which here you can see. So what it's saying that reading book and backslash n means there is something in the add to do function. Let's go into the add to do and where it's yeah right here task input. It's directly storing the task instead of trimming. So we can add right trim dot to okay now cargo test reading book. Now the test gets passed because the right hand side is equal to the left hand side. We were expecting that the input should be reading book and the output and the data I have passed as an input was reading book and it's successfully passed. If I write wrong input, which is not expected here, so it will throw an error. So right now I'm writing the basic functionality to learn about how to write tests. We can uh, test furthermore large scale applications, but for now we are just testing the smaller functions. In production, we don't write the test like this. We don't compare the first index of an array with the static input that because I have passed the static input. It's not a good way to write test to compare with static or the static string with the dynamic string expected from the user input. So now let's move on to the uh, let's move on to the uh, okay, one more thing we can do one thing here. We can write another test here. So let's close this. Now, unexpected token in input, no rules expected test view to do's because I cannot, I'm unable to, oh, what I am doing here. Instead of doing this, we can, now what I have to test is the functionalities. Let's go back to the main menu we have. And furthermore, we can also simplify this main menu with by adding enums. So we can add like enum for instead of writing one, we can write enums and match it like that. So you can enhance this to do application on your own as well with different implementations. You can share it with me so we can discuss or I can bring it over this video. So let's test this function edit to do. So edit to do is expecting tasks as an array or vector of tasks, and then it takes an input from user. It will task.trim, it will edit the task. It's not returning anything. You can see it's not returning anything. So what we can do, um, we can implement the edit functionality for now in this test add to do function. We will separate it out later on. So let's do one thing, edit to do multiple tasks. Yeah, so video is working fine. Okay, perfect. So let's what's cannot find value tasks in this scope. Okay, after asserting, oh, why the task it is to do's, my bad. To do's, and then let's do an assert. Let's just copy this and it will be good. Let's just test this function, the implementation, cargo test. It is expecting me to enter reading redos, sorry, reading. Oh, and then let's say I want to update the number one. There is no any number one index out of bound. The length is one, but the index is one. So I have to pass reading row number zero, and then the test is, yeah, we can see. So you why there was an error, because we only have one single index and I have passed number one. So if I want to test the application, the to-do application, let's just recall the recap the flow of the to-do applications. Argo run one for view all to-dos, we can write two, add a task to do reading. So now I have one task, task zero, reading book. If I want to edit a to-do, enter the task number. Task number is zero. So I have to write zero, and then the task is edited. If I want to view all to do's, you can see task zero, the is completed status is becomes true. The Boolean is updated. So now if I want to separate out this functionality and move it into the separate function, it will work perfectly fine. If I don't want to do that, we can go test. So it's my choice that if I want to move it or not. So you can see two tests pass because it's in a single test. We cannot consider it three tests. It's one test and the second test. There are two tests. It will not consider it will not be dependent on the hazard equals to the hazard macro. So if I want to separate out this functionality, functionality I can do that. Okay, so let's move on to the documentation. Yes, let's zoom in. I forgot to zoom there. Okay, so now cargo test, they are testing different functionalities. They have tested it with struct and everything. So because we have already tested the advanced functionalities through to-do application, so there is no need to retest all these implementations again and again. So you can see they have created a struct implementation of this gas struct. They have created a new function within that implementation, and then let's review the test hash test. And it they are saying that it this function this test should panic, means gas new, it must panic, because let's say if gas new, they have passed input 200, so value is less than 1 or value is greater than 100. Yeah, it is greater than 100, so then it will create panic. So it should create panic. If it is not creating panic, the test will get failed. If it is creating panic, so the test get passed. So this is pretty much it from this chapter 1, 11.1, I guess. Yes, now move on to the 11.2, controlling how tests are run. So let's do one thing. 38 minutes. So okay. So just as cargo run compiles your code and then runs the resultant binary, cargo test compiles your code in test mode and runs the resultant test binary, the default behavior of the binary produced by cargo test. So if I want to, let me open the Excalibur. Uh, I think we should discuss about the program is will be after compilation. So let's say initially, let's say this is a Rust program. This is a Rust program. It will be moved to the, let's say, it will convert it to the binary. There we will Rust will, when we do cargo run, it will create binary of your program. By first of all, it checks through borrow checker. It checks the borrows that we have implemented, borrow checker, type checker. So these are the checkers that will be implemented, and it will create binary of your application, and then you can further create, and it will move on to the, after creating binary, it will the program will run executed from your binary application. So let's say compiles your code and then runs the resultant binary. Your program by default, it will not run directly. It will, the Rust will compile your code after, let's say your program cargo run, it will compile your code by borrow checker, type checker, and then after it will create your the binary of your program. So let's move on to the some command line options go to cargo test and some go to the resultant test binary. Separate these two types of argument you list. Okay. I guess we haven't discussed about the CLI applications that, let's say if I want to, we will create a terminal through Rust later on in our upcoming videos. So let's just discuss about how we can access the clear it. So mm, close this terminal, control V, main function right here. Let's just comment this out so that we can test or we can create a separate program. Instead, just go into this one. Yeah, right. Create a main.rs flag so that I can remain. Yeah. Okay. Now here I want to access the argument. So let's say print ln fetch. Okay. And if I write cargo run, the program is running and I can see the hello. So what if I pass cargo run and let's say any of the arguments here, hello, how we can access this hello in our Rust program? So we can access the CLI arguments through std env. Okay. So now we can get all the arguments passed after cargo run command. So let's say I can let args equals to argument dot let dot. There are multiple options that we can opt for or we can choose. For now, just let's do one thing. You can see double what happened args my bad and then dot select. Okay, so let's say I let's print it out. Arguments are cargo run hello. What happened? Consider given args as an explicit args one, args one. What happened? Why it's not? Okay, so type annotations needed multiple implementations satisfying found in the allocate. So what we have to do now that required by abound and collect, because we are collecting all these arguments. Let's say if I remove this collect, what will happen? It will get me all the arguments like this inner, and then first argument is the target debug lecture 9, the path of my directory of or from where I am running this program, and then the second argument is hello. There are multiple options. Let's say cargo run, and then if I pass minus minus, so now it the Rust will consider all the everything after this dash dash as a CLI argument. So let's say uh, what can we do? Let's say grab, let's say we can, let's just do A, B, and C. So now you can see grab A and C. So now you can see that each and every argument will be separated out through you by a space. So whenever I'll write or add a space, it will consider it as an index of, or consider it as a separate argument. Let's say grep is one argument, A is another, and the and C is another one. So let's move on to the documentation. Okay, running tests in parallel or consecutively. So you know that Rust runs all the tests in parallel. So let's say, because to make the Rust language efficient and the testing efficient, Rust runs all the tests at once in parallel. So let's say एक thread में कोई test चले, एक thread में कोई और test. So Rust runs all these tests in different threads to make it faster and efficient. So what if I want to run each test in a single thread? So let's say if test is, let's say I have written 10 tests. So what I want to run all these tests one by one. So let's say if test one, number one is passed, then it will run test number two, then three, and then follows on the 10th test. So you can see that cargo test minus minus. And if I want to run the test in a single thread, in one thread, so minus minus test minus threads is equals to one. You can define what number of threads, any number of threads you want. So let's say one, two, three, but it's not good, or uh, if there is a requirement, you can opt for it. You can use this method. If you don't want, by default, you should use the efficient ways to run all the tests in parallel consecutively. Showing function output, you can show per function output. This will pass, this will fail. You can print out something if you want. So now it's running the tests. Okay, now print ln, we cannot, we are unable to see. I got the value 8. Right here you can see the test, this test will fail, std out, I got the value 8. And then with minus minus show output, if we want to see printed values for passing tests as well, because if a test is passed, it will not show you the print statements. So if you want to see the output, so you have to write minus minus show output to see the output. So let's say if I go on the to do application, so right now if I want to see the output, I'll go test minus 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 to output. Let's say uh, during the uh, test number one is failed, add a task to do, and this. What if I don't want to, and without reading book, let's, this test will successfully pass. Yeah. Right now you cannot see any of the outputs here. If I want to see the outputs, you can. All the tests are passed. You can see the print statements right here. Woohoo, there is no pending tasks to do, and so on and so forth. All right. I guess this is pretty much it from this topic. Running a subset of tests by name, you can run the subset of the tests by their names as well. So there's no issues with that. Result led to, sometimes running a full test suite can take a long time. If you're working on code in a particular area, you might want to run only the tests pertaining to that code. You can choose which test to run by passing cargo test the name. So let's say if I want to run only this one, this test, so you can write cargo test minus minus and the name of the test. Or with the simple command cargo test, it will run all of the tests. Yeah. So I think it's understandable or it's easy. So let's move on to the next topic, 11.3, test organization, that we have discussed in a few minutes or a while ago, that we can organize our code by moving all the tests into a separate directories and separate files. So let's start with this. Test organization, as mentioned at the start of the chapter, testing is a complex discipline and different people use different terminology and organization. The Rust community thinks about tests in terms of two main categories: unit tests and integration tests. Unit tests are small and more focused, testing one module in isolation. Unit test means testing different functions and everything, isolation at a time, and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would. So this means that the integration test means that the testing of different functions or methodologies uh, as a external user kind of thing. Let's say I'm the application user of an app of an application. So the integration test means the user experience kind of thing. Let's say what the function will uh, how this function will respond to the user, the external ones, or the public environments. So a public interface and potentially exercising multiple modules per test. Unit test. The purpose of unit test is test each unit of code in isolation from the rest of the code to quickly pinpoint where code is and isn't working as expected. Unit test is this. We have already discussed about that. So now let's move on to the how they are organizing their code. So now they have created a separate file, a separate directory test, and then they have created a file integration test.rs. In here they have created a test and then use adder add to. What this means that they are using the adder. Let me show you. Where is the adder? And then adder is the parent directory, and then add to is the function inside the main dot lib.rs. So let's take an example here. We have a function add and subtract. Let's create a directory test or tests, and then we can create let's say mathematical functionalities or mathematical testing. .rs. Okay, so now let's say if I want to test the add function, so I can do, I have to write the name of the package lecture 9. So or instead I can, starting with the test, let's just copy the test where it is. Yeah, test subtract. Okay, let's just test the subtract. Now how can I access this subtract function? And one more thing, we have to access this test library, the test directory into the library. So how we can access this? We have to click. Now you can mm, let me show you how we can use that. They haven't updated the lib.rs, and now internal adder, this is the internal adder, and the add to will run this add internal function. And then let's move on to the lib.rs integration test. They have just created a test, and then they are using the add to function from the parent directory. So let's do here the same thing here. Go on the cargo.route. In here, you can see the name of the package is lecture 9. However, I cannot, you can see the opacity of this file is reduced because it's saying that it can, this function, this module is not accessible. This file is not included anywhere in the module tree. So what does this mean? That we have to define it in our module tree. So how I can do this? I can do one thing mod and then just pass the direct name of the file that we will be using. Now you can see here it's accessible, it's working fine. If I want, because it's saying that cannot find function, so how I can do, you can do the same thing, use create. Now what does this mean? Go back to the one step back in the directory structure and access this function. And then now you can see, if I do test, it will run the test, and assert not equals to, if I do, it will be equal to, and the test get failed. So this is the thing. Let's move on to the next submodules in the integrating test. So they have created different modules. You can create different nested folder structure or the directory structure. Let's say if I want to create some common functionalities as they did, so I have to, how I can access, let's say, instead of declaring let's just move this file mathematical test.rs in this common. So now here you can see that mod mathematical test cannot be accessed. So how we can access this mathematical test? You can do mod.rs to create a modular structure, and then use, oh sorry, mod, and then we can write mathematical test. And here you can go with common. Now you can see you can access mathematical test, cargo test, the test will run, test get failed. So now it's working perfectly fine. If I, let's say if I am not doing anything here, what what happened? Yeah, right here you can see the opacity get reduced. It means that this file is not included in the modular structure, or modular uh, module tree of the Rust, or this program, or this library. Yeah, this is pretty much it. We have tested Todo application. We have learned about how we can organize the test, or how we can organize our Rust library. And then let's read out the summary, and then Rust testing features provide a way to specify how code should function and to ensure it continues to work as you expect even as you make changes. Unit tests exercise different parts of a library separately and can test private implementation details. Integration tests check that many parts of the library work together correctly, and they use the library's public API to test the code in the same way external code will use it. Even though Rust type system and ownership rules help prevent some kind of bugs, tests are still important to reduce logic bugs having to do with how your code is expected to behave. Let's combine the knowledge you have learned in this chapter and in previous chapters to work on a project. So in the next chapter, they are creating, or they will be developing a CLI application. So we have already reviewed or covered that how we have learned that how we can access the arguments of a lab of CLI, how we can, let's say if I pass any argument in the CLI, how we can access into the Rust program. So if I want, I guess time has exceeded, is it's almost around 1 hour. So let's uh let's create this project in our next video. So I hope you have learned a lot of things from this video. If you have any questions, just let me know. Um, there are a lot of new developers coming in and viewing these videos, the course. So I welcome you all, and if you have any questions, just let me know. So uh, I'll try to be more responsive, and I'll try to answer your queries in the video as well. So let's move on to the lecture number 12 in our next video. So for now, that's pretty much it from my end. So let's see you guys in our next video. Till then, bye.